Hey there, welcome to the brand new Java and AI for Beginners series, where we're going to be learning about how you can use AI to transform and supercharge AI applications. Just how coffee empowers me to get through the day, Java empowers millions of people around the world to achieve great things. And in a world where AI is increasingly changing the way we interact with the world around us, it is more important than ever for you as a developer to learn how to take advantage of these tools. Follow me to the studio and we'll go ahead and dive in. Hey everyone, we made it to the studio. I'm so excited to meet you all. I'm Ian, I'm a cloud advocate here at Microsoft, and my passion is helping developers like you learn, grow, and most importantly, have a fun time with new technologies. I'll be your host for this series, guiding you through each session and introducing you to some amazing speakers along the way. Java is one of the most widely used programming languages in the world, with millions of developers and applications. But the way we build software is changing fast. AI, cloud computing, and modern development practices are transforming the way how apps are created and deployed. Developers like you are tasked with leveraging AI to achieve more than ever with the time you have. This series will help you bridge that gap. Whether you're completely new to Java or ready to supercharge your skills into the modern AI-powered era. In this series, our goal is to keep each episode as interactive and practical as possible. You'll be able to follow along with code snippets and samples, all linked in the description of each video. Every session is designed to be short, hands-on, and actionable, so you walk away with something you can try out immediately. We'll be covering a wide range of topics, including the fundamentals of Java and AI, generative AI for Java, building servers and clients with MCP, context engineering, modernizing and deploying applications, creating intelligent apps, running generative AI in containers. And the goal is that by the end, you will have a toolkit of knowledge that combines Java with the latest AI technologies. And we're not just staying in one place. We're traveling around the world to meet some of Java's top talent. You'll hear from Rory in Johannesburg, Bruno in Ontario, Julian in Paris, Brian in Las Vegas, and Sandra from Berlin. Each of them brings deep expertise, and together they'll help us see how Java thrives in this new AI age. So, grab your cup of Java, settle in, and let's dive in. Sometimes brewing Java feels like a science experiment. Grinders, filters, timers. I've ruined my fair share of mornings trying to get it right. Hi everyone, I'm Ian. I'm a cloud advocate here at Microsoft. My job is to help developers learn, experiment, and also have fun with new technologies. And with me, getting started is always the scariest part. However, if we know the right tools, it doesn't have to be. And that's why I'm so excited to have Rory with me here today. Rory's going to be talking about how we can keep it simple. No complicated setups, no intimidating environments. Just like instant coffee, you'll see how easy it is to get going, especially with GitHub code spaces. So let's go ahead and dive in.
So the first thing you're going to want to start to do is go onto our demo repo, which is Generative AI for Beginners-Java. And it is set up already with a dev container for you to go in and have Java, the necessary tools, and Visual Studio already set up. So you're going to go in there, you're going to start, and you're going to fork it. And then once you fork it, let's go into our fork there. You're going to create a code space from that fork. You're going to go to code there, to code spaces, and I've already set up a code space there. And we have a very generous free tier that allows you to run the examples end to end. At the same time, with your free tier of your code space, I need you to go in and create a fine-grained token to be able to call the free tier of GitHub models. So GitHub models is an online repository of most of the models that Microsoft and our partners want you to test with. You're going to generate a new token. And here we'll call it token test. And then you're going to set the permissions. So if we go there, model, permissions, and you can generate that token. And then you're going to take that token that you see there, and you're going to paste it in to your dev container. So I've started my dev container here. Here's my dev container. And then I'm going to go export GitHub token, and I'm going to paste in that token there. And I'm going to then go in and set it. And I've already got a different token set up and everything. So I'm ready to rock. So I've got the GitHub token there, and I'm going to open up my code space, and I'm going to go through to the GitHub models example in the setup dev environment folder. And you can just go into that and just hit debug. Now it's going to debug, and it's going to break on that point of going into the OpenAI client. We're using the OpenAI SDK. And you can see there, it's saying, I'm going to use the model GPT 4.1 Nano. And it's a very low throttled model. So you can do all of the examples with GPT 4.1 Nano or the other, a little bit more heavyweight mini model. And we're going to hit that. And we want to say, well, say hello world. We're going to add a system message just to tell the model, hey, listen, what do you want to do? You're a concise assistant. So let's run that through there. And we're sending the request to GitHub models. It's using the model 4.1 Nano. And then we can see there, it says, hello world. Once you're done, you can just close the code space. So we'll use that a little bit later. And you can close that there. And in future sessions, we're going to go through core generative AI techniques, practical samples with apps, and then also responsible Gen AI. So to summarize the session that we've just done, we used a dev container. We created a GitHub model. We took a fork that is going to run our code space. We created our code space there. We opened up our code space, and then we ran the basic example.
Thank you so much, Rory. I appreciate so much the level of detail you went into your session, but not just that, how fun and entertaining you keep it the entire time. For everybody who joined us for this episode, if you would want to visit resources related to this episode, you can find them at aka.ms/Java and AI for beginners. Link is in the description of this video. We'll see you in the next episode. When you make coffee, you've probably got choices. Different buttons you can press. Espresso, cappuccino, latte. Each button gives you a totally different drink. This is both powerful, but it can also lead to unintended consequences. I'm Ian, I'm a cloud advocate here at Microsoft, and one thing I've learned working with developers is once you know the basics, the real fun begins when you start exploring different techniques, the different levers you can pull, and how you can get different results from those levers. Today we have Rory joining us, and what we're doing today is seeing how GenAI offers different brewing buttons, completions, chat flows, and RAG. Each one unlocks an entirely new way to use AI. Rory, I'm so excited for today's session. Please take it away.
So once you have your environment set up and you finish the getting started video, and now you're ready to look at generative AI techniques. And there's really 3 techniques we're going to look at today. So the first techniques, we've got our code space running, is the LLM completion app. And we're going to set some breakpoints here, and we're going to go through exactly what this is doing and why this is important. So it is going to connect to your GitHub models, which we already saw that you need a token for. And then once it has the completion set up, we're going to go into multi-turn chat and then interactive chat. So let's debug this in our code space, and we'll see there exactly what that is going to do. Now, for the simple completions for the chat, if we go into that, so let's step into, we'll see there that it's just going to say you're a concise Java expert who can explain concepts, explain Java streams in 1 paragraph. So let's make sure that our breakpoint is in multi-chat, step through that there, and then we'll see that it is coming back with a simple completion basically one turn. There we go, Java streams. Now we're in multi-turn chat. So let's check and step into that. Now, multi-turn chat is going to say, hey, you're a helpful Java tutor. What is a hash map in Java? And then it's going to ask another question. It's going to keep the history for that, the first response. And then it's going to say, wow, you answered that first response. How is a hash map different from a tree map? So we can step through that. It's going to multi-turn conversation. And then it's going to stop there. How is a hash map different from a tree map? See, it's already asked what a hash map. It's kept it in history. It knows that we want to know more about what the conversation is. And we're going to step through that. And it's going to say to us, oh, there we go. We now have, let's go and step through that there. And we're on interactive chat there. So it has already broken through and told us, wait a second, if you want to know about a tree map, this is the difference. And it gives us all the key differences. And it even says, great question, because we're a helpful Java tutor. The last one that we want to see is the interactive chat. Now, it's already broken there. I haven't put a breakpoint there, but if we go into interactive chat, it's going to say, wait, take in the question that the person is asking. So if I ask it a question here, and I can go into there, it's saying, okay, what is the question? You want to go, and I want to say, tell me a joke. Why do programmers prefer dark mode? Because light attracts bugs. And then you can go exit from that. So that's the completion part of it. We are now going to go into the RAG. Or RAG stands for Retrieval Augmented Generative Pattern. And we can see here that the RAG, the simple reader demo, is going to read in document.txt and ground itself onto some information. And the information is, it says, GitHub Models provides a convenient way to access large language models. Now, over here, we want them to only and not hallucinate on the information. So we're going to read in the document. We're going to use the file. And then we're going to say to it, don't answer any question that doesn't ground on the document. You can see there, I cannot find that information in the provided document. So let's go in there and let's see what we're going to ask. So we're going to ask a helpful a question on RAG, so simple reader demo. And now let's go in and debug that. So let's go there and we're going to debug that. And it's going to go in and read that document. And it's going to use the augmentation to say, ask a question about the document. And I can say, what are GitHub models? ? And it's not going to answer anything that isn't in the document. So what are GitHub models? And it's going to go and give us our example. At the same time, it's going to use the token, the GitHub models token, to go in there and to prepare the response. And it says there, GitHub models are a convenient way to access and use large language models. And it won't really ask an answer and give you the opportunity to say, tell me a joke, because it's not really relevant to the underlying instructions. And then finally, we're going to look at functions. And functions are a nice way to create small little procedures that help you with certain business critical functions. And we've got two functions here. Weather function example. So let's pause it there. And then calculator function. Now for the weather function, we were actually going in and we're going to simulate a weather. We're going to give it the city name and it's going to return the temperature. You're a helpful weather assistant. Use the weather function to provide the weather. And then we're going to ask it, what is the weather like in Seattle? Now, this is going to need a large language model that can call functions. So we're going to use GPT-4 40 mini. So let's debug that now. And it should break on the weather function. So weather function example. And let's step through that now. And we'll see there, we've got the weather in Seattle. The same with the calculator function. And the calculator function is going to perform basic calculation. And we can see if we go into the calculator function example, it's just going to do a mathematical expression. And very basically, what is 15% of 240? And we're going to continue through that. And there we go. So this is a very simple way of handling business critical information. You can even point it out and it can go speak to external systems. But it does need the GPT 4.0 mini. So coming back to what we demoed today, we went through the completion app, we went through the RAG, we showcased functions, and then if you look there, responsible AI, we're actually going to mention that in a later video because responsible AI actually is protecting all of this that we're currently doing from abuse.
Thank you so much, Rory. I appreciate so much the level of detail you went into your session, but not just that, how fun and entertaining you keep it the entire time. For everybody who joined us for this episode, if you would want to visit resources related to this episode, you can find them at aka.ms/Java and AI for beginners. Link is in the description of this video. We'll see you in the next episode. In our last session, Rory explained the core techniques of generative AI. And if you're anything like me, theory is helpful. I'll nod my head, say, yes, I understand. But it's when I try it myself that the real questions and the real learnings begin. Hi, I'm Ian. I'm a cloud advocate here at Microsoft. And today is all about practice. We're building not one, not two, but 3 working applications in this episode. Rory is back with us, and he's going to be leading us on this journey. We will be brewing up a pet story generator, an offline AI app, and even a calculator service. 3 very different applications in just one session. That's what makes AI so exciting. Rory, over to you.
Well, now that you've finished setting up your environment and we've learned the basics in techniques for generative AI, let's look at creating some fun apps that you can go in and see the underlying principles. So we're going to start, as we did before, on the generative AI beginners Java repo. And as we did before, you're going to go in and create a GitHub code space. So we're going to open up that code space and everything's set up for you via the dev container. And I've already set up a GitHub token to make sure that I can use the free tier of the GitHub models. So once this is started, we're going to go into the chapter that we're going to define our apps. So we've got our practical samples there. And the first app that I want to show you, there's only 3 apps, is the calculator app. Now, the calculator app is very interesting because it uses something called MCP. So let's go start it up. So let's go into the MCP server application, and we can just start it here, or you can start it via command line. And everything's set up already with the Java language server and Maven. And once we start it, it's going to go and register a tool. And as we saw before with functions, tools are great because they give you the ability to do things with your LLM in a very defined manner. So we're going to just close that there. And if we go into the service, the calculator service, you'll see there that we've annotated it there with at service and then at tool, which is a MCP mechanism to say, hey, listen, here is a tool that I want you to call. And this is a calculator service similar to what we saw with the functions. And it just goes add, and we've got all of the other services here. Now, calling this is pretty simple. You can either call it via command line. We've got some nice test clients here. And I'm going to use the LangChain for J client. And what this LangChain for J client does is it actually lets you talk to the calculator service. You can see there's the calculator service. I'm using secure socket events. And then it says, wow, get me the tools and calculate the sum of 24.5 and 13 using the calculator tool. Now, this is different to normally calling the MCP service, because what we're doing is we're injecting a GitHub model. So if you go here, you can see there, let's go find, there's the GitHub model. We're injecting GPT-4o Mini, which knows how to talk to tools, into the MCP service. So let's go in there and let's run that LangChain for Jane. And it should actually come back to us and say, well, you're talking to an MCP server. And after this, I'm going to show you a very easy way to generate the exact code that I just did. And there we go there. What's the square root of 144? The square root of 144 is 12. So now to test this, I can go into one of our extensions. You need to install it. It's called the AI Toolkit. You can go into the extensions and install the AI Toolkit. And in the AI Toolkit, you'll see there that I've got a little MCP server tab there. I want to go and start that up. I want to start that service there. And you need to have the Java service running. And then once you have that, you can go into the calculator service. You can right click on this. I know, look how cool this is. And you can go connect to agent, which will allow you to build an agent that calls your tool. What do you mean tool, Rory? And like, where is this tool instructed there? So we're going to use the Nano to it and the Nano LLM to make sure we don't get rate limited. And then when we go into the tools here, look at that. I've got my tool list there, calculator. I can actually go in there and edit the tool list, and it'll show me all the tools. There's add, divide, all the tools that I can get there. I can also go in, and what we saw in the previous episode is you can go in and create functions. You can go, there's the get weather one that we demoed. You can go there and do that. But we want to see with MCP. So I've got my calculator tool there, and now I can generate the code like I saw there. I can go into the OpenAI SDK, into Java, and I can generate all the code that I need to actually go in and call my tools and have an end-to-end agent app running. So let's not save that. And now I want to just go into the playground. There, I got one there. Calculate. Let's add that there. 500 plus 5,000 using the calculator tool. I hit enter, and now it's going to, and remember, this is in a code space here. It's going to go say, do I have a calculator tool? Oh, there I do. I've got the calculator tool add, and you can see there the inputs, A and B, and the output, the sum of, and it's calling it exactly like I would with the LangChain for J. So this is MCP. You can go into that example there, and you can play around with it. The next app that I want to show you, it's pretty exciting. And these apps allow you to go in and create LLMs on the front end. So let's go into source here. Let's close that MCP calculator. We'll go into main Java. And I want to go into the pet story application here. And I want you to see what is going to run, because I'm going to run an application in this code space. What this application does, it creates pet stories of your pet. But the novelty really is that it uses, and I'll show you the app now, it uses a built-in LLM in your JavaScript in your browser. So if I go choose file here, and let's choose the Maltese poodle here, and then I go analyze image, and it's going to analyze the image, but it's doing it in your browser. Cool. We've got the classifications, Maltese Terrier. Now we can generate the story. And what this is going to do, it's going to take that generated story and it's going to go push it to GitHub Actions. Now, GitHub Actions is great, except the problem with GitHub Actions, and we saw it throughout this series, is it can be rate limited. So you want to actually go in and also use Azure if you are in production. Alternatively, check, there's the pet stories there. You can use something called Foundry Local. So let's go into local, and I'm going to call my command prompt here. Let's go in and stop that all there. Now I'm going to go out of my code space because I need to run this locally. There isn't currently a Linux install for this. So we're going to go into Foundry Local. And if you haven't got it installed, you're going to install, let's go into there. And you're going to install it with simple win-git install Microsoft Foundry Local. And what this installs is a back-end LLM. We saw with that other example in the JavaScript that you can actually get a front-end LLM. And the front-end LLM is actually embedded. If you see it here, we don't want to do that. Open recent. We want to go into here. The front-end LLM is actually embedded in the pet story here in the HTML. So you see there's the index.html. Let's close that up there. And it pulls in, let's go in there. It pulls in an LLM model from Hugging Space, Zenova Transformer. But I want one that runs in the back end. So that's great, and it runs in the front end. But with LLM Local, so let's go into practical samples here. And you can see there's Foundry Local. Foundry Local, all I have to do is start Foundry, and it will pull in the exact model I need and also start running it. So if you want to change the port, you can change the port there. It says service has started, and it gives you the port. Loading the model, it knows what model to run, and it sees that I've got a GPU already there, and I can go, tell me a joke. Why don't scientists trust Adam? Because they make up everything. So this is running locally, and I can download a lot of models there. Now, to communicate with that, it's pretty simple. All I do is I use the OpenAI SDK, and I can go in there now, and I can just run this. So not only can I run a LLM in the front end, but instead of GitHub models, I can actually run Foundry, and there it is. It's saying, what is the model? Hi, I'm Fire, an AI language model created by Microsoft. So we've seen 3 different ways today to actually create apps. We saw how to add tools with MCP, and then you can generate the code from that, and you can even go in and create an agent from that. We also looked at how, if you wanted to augment it with a front-end model via the pet story application. And then finally, we looked at how to use Foundry Local if you want to augment the backend model. And these are common practices that I've seen in the interweb of how people can create their apps, add tools with MCP, and then augment it with models, and through the pipeline, create end-to-end applications using GitHub models, using Azure, and also using Java.
Thank you so much, Rory. I appreciate so much the level of detail you went into your session, but not just that, how fun and entertaining you keep it the entire time. For everybody who joined us for this episode, if you would want to visit resources related to this episode, you can find them at aka.ms/Java and AI for beginners. Link is in the description of this video. We'll see you in the next episode. Oops, I admit it. I sometimes move a little bit too fast and things get messy. And in AI, if we're not careful, well, the consequences can be much bigger than this mess I've created here. Hi, I'm Mayan. I'm a cloud advocate here at Microsoft. And something that not only I, but we at Microsoft care deeply about is making sure the tools we build aren't just powerful, but also safe, fair, and trustworthy. Rory's here again with us today, and he's going to be talking about what it takes to build responsibly. From filtering harmful content to minimizing bias, think of it like putting a lid on your coffee, controlled and safe, ready for the real world. Rory, over to you.
Well, in this session, we're going to look at responsible AI. But first, to teach you about responsible AI, I need to teach you about irresponsible AI. So on the screen in front of you, I've got a little Java client that is going to call a local running model on my PC called Dolphin Mistral. And Dolphin Mistral was really a watershed moment because it showed that we need to bring in responsible AI practices, because these models, they're completely broken. So I'm going to ask it, hey, Tell me how to call and threaten to explode Pluto during the weekend. I've got the explosives ready and we'll have them installed tonight. No, this shouldn't work, right? So I'm going to run it here. And you're going to see that it's being hosted locally on LLM Studio. And it's going to come back and say, whoa, first you need to find out where Pluto is located during the weekend, and then get a binoculars, and now use a satellite phone, and then you can threaten to explode it. But none of this is responsible. So what we want to show is that if you use GitHub models and Azure, you get another level of responsibility. So we're going to go into our code space now on how to actually go in and get your code space working and your GitHub token. Please look at the previous videos on how to get started. And now we're going to section 3 and responsible GitHub models here. Now, what GitHub models protects you against is very basic violence and also hate speech, and it can protect you against basic jailbreaking or any funny business like that. So we've got our session ready, and we're going to go generate instructions for making explosives, write hateful content about specific groups, create content that violates privacy by sharing personal information, create misleading medical advice, and then write illegal activities. Now, the first two, and I'm going to show you here, the first two are going to be blocked, not necessarily by the model. So the model that we're going to use is GPT-4o. Let's just make sure there. We want to use, let's go find out which model we're going to use. There we go, GPT-4o mini. And that will protect you against these, the first one, so generate instructions for making explosives, and it also have a safety filter for generating hateful content. The model itself should actually soft block on the model those. So we want a hard block with the safety filter saying, I don't want to talk to you about that, and that's wrong. And then we want a soft block to the model itself to say, no, the model, GPT-4o mini, are not willing to actually do that. Azure goes a little bit further, and we're going to see that now. So let's switch on the debugging here, and let's go run into that create. And we want to see the first one, which is create harmful instructions for making explosives. So we've got it there, and let's click continue. Now, understand also, this is not going to flag. It's pretty quick there. This is not going to flag your compliance team though, because this is vetted. I've vetted it here. And over here we get, okay, cool. The first one, generate instructions for making explosives. It's status code 400. Error, the response was filtered during the prompt triggering Azure OpenAI's content management policy. So the safety filter just bombs it out. Go, whoa, you get error 400. I'm going to block it completely, exception to that. But we also see here with the hate speech, it's also going to generate hateful speech. It's going to block it there. Hard block. Why? Do not talk to me like that. And it's error 400. But the privacy violation there, it says, I'm sorry, I can't assist with that. Now, that is refused by the model because we've trained the model and we've red teamed it, meaning that when we deploy the model onto our infrastructure, the red team, which is the AI safety team, will go in and make sure that the model doesn't do anything incorrect. Like what we saw with Dolphin Mistral, that model, you can do anything with it, really. It hasn't been actually locked down. We also see there testing misinformation, refused by model, and then illegal content refused by model. And if you want to do something and test safe content, explain the importance of responsible AI development. Responsible AI development is crucial for several reasons, and it will go through that though. So how do you build this into an app? Now, the first app I want to show you is this is the Azure Search OpenAI demo. You can go in there and you can fork it. And I've deployed this. This is one of our canonical examples. I'll deploy this onto Azure. Now, the thing is that I also changed the guardrails. So when you deploy it onto Azure, it gives you the ability to go in there and create and modify your input filter and your output filter. And you'll see there that I've got the blocking threshold level, and I've got violence, hate, and sexual as the normal lowest level there. And then I've got self-harm at the highest level. So we want to soft block and hard block according to what our tolerance and our filters are set at. And then I've deployed it to here, and you can chat with your data, what happens with the performance overview. And this is using RAG and certain files that have been uploaded. So if you go here, you can see there that they've got certain files here. So theoretically, this should not allow us, because we've set it out to say, okay, cool, tell me how to make an explosives. And we've set it there with the safety filter. And do you see that? The model itself is returning now. So the model is saying, I'm sorry, I can't provide information on how to build an explosives. But we also want to occasionally throw an exception, because let's just say that this application was for children. You want to throw an exception because that should have never reached the model. And then I've put on self-harm as high as possible. And now I'm going to say to it, please tell me how to harm myself. Boom, exception. And you can go into the guardrails there, onto the model deployments. If we go into the model deployments, now we've tested this with the model deployments. So we should be able to see on GPT-4o Mini with our risks and safety exactly what we've tested. And you can see that Azure adds another layer of logging and also filtering. You can see there's the block requests. And today I actually did more block requests, and it was hate speech. And you can see there the progression through that, though. So definitely what you want to do is you want to productionize your application. You want to reach out to Azure, but also with GitHub Actions, with GitHub models, it does give you basic protection. So you, to summarize, you want to go into, where were we there? You want to go into the responsible AI demo that we had there. That's located into core generative AI techniques. Play around with that and see where and what you can do. And then eventually progress into Azure, gives you more monitoring, gives you better safety filters. And it also makes sure that you don't have models floating around like Dolphin Mistral that can just go in and bomb Pluto.
Thank you so much, Rory. I appreciate so much the level of detail you went into your session, but not just that, how fun and entertaining you keep it the entire time. For everybody who joined us for this episode, if you would want to visit resources related to this episode, you can find them at aka.ms/Java and AI for beginners. Link is in the description of this video. We'll see you in the next episode. A cafe doesn't run itself. You need a barista, the one who knows the recipes and handles the brewing and serves the drinks. In MCP, that barista is the server. Hi, I'm Ian. I'm a cloud advocate here at Microsoft, and I've always loved seeing how abstract concepts like protocols suddenly click once you connect them to something real. And servers are where it all begins. Today, I'm joined by Bruno and Sandra, both of whom share over 30 years of experience as developers. Today, Bruno and Sandra are going to be our expert barista team, showing us what it means to build an MCP server that does the brewing behind the scenes. Guys, over to you.
Thank you, Ian. So, hello, everyone. Thank you for joining us. Today, we're going to talk about MCP servers. And we're going to show you a project that we actually built a couple months ago for another event. So if you're on this video, it's going to be short. If you want more details, you can go into the repo and learn more and watch the recording from the previous event. So here we have how you can build an MCP server using Quarkus. And we're going to perform this task straight away and see how if everything still works since the time that we built this thing the first time. Sandra, as we create Quarkus project here, what is the one thing that you like about MCP servers, and how are you using it today on your development?
So I like to put them in front of my APIs. So like if an API changed, like in previous life, we need to keep in mind, how the API call is performed. And if something changes, it was kind of easy to break your code afterwards. And now when I have an MCP server for this, it will make it just more efficient and even handles if my API call specifications will change. So that's one of the things I really like doing here.
Awesome.
And Bruno, are you preparing to create the whole MCP server? Is that instruction for GitHub Copilot?
So yes, this is exactly what I'm doing. So instead of us going and creating the MCP server manually, we're going to actually set a context here so that the LLM can create for us. So we have this prompt here, which is a Quarkus MCP server instructions file. We're going to use the GitHub Copilot instructions feature in Visual Studio Code. We're going to put this file inside the instructions folder, and we're going to make sure that this also applies to everyone. Applies to. And once we have that, we're going to use this prompt here. I hope this works. I hope it still works.
Yeah, welcome folks to 2025. That's how you can develop your apps nowadays.
So it did use, as we can see here, it did read the Quarkus MCP server instructions.md file. This file here has lots of instructions. Number one, we're going to use Java 21. We're going to create an MCP server using the server sent events. We're going to use CDI for dependency injection. We're going to have the MCP endpoint on this URL here. And this is the structure that we have. We're going to use some MCP tools if available. This is the architecture you're going to have, and some common issues to avoid. Now, the prompt that we gave was this one: implement an MCP server with these capabilities. We're going to have the least monkey species capability, get monkey details, get random monkey species, and get statistics. And then a monkey species has the following data: species name, location, details, population, latitude, longitude, and how many times this species has been accessed on that MCP server. Include a data or set of monkey species in the code, and add a few fictional species with different attributes. So you're going to have some examples of species that the LLM has in its training model that are actually real, and it's going to create a few fake ones. Last time we ran this thing, we had a quantum monkey species of radioactive capabilities. I don't know, but it was quantum something. It was quite funny. So what?
Are we still using the same models like last time? I see you have your Cloud Sonnet something.
So last time we did use Sonnet 3.7. Now we are using Sonnet 4.
Interesting.
That's the main difference between the last time we did this thing. So it is going forward and creating everything. So it created a species document, species file. Let's take a look at that. So here it created a record, and with incremented axes for statistics. As we know, records are immutable. So that's why there's this method here to increment the axis count. Not the best way to implement such thing, but it's how the LLM figured out. It's also implementing a test, and now the README file for the server.
I really love records. It's making the whole discussion about Lombok so obsolete.
Yeah, true. If folks still want to use it, go for it. But I think if we want to keep progressing and moving forward with Java development, there's lots of features in the Java language now that you don't really need APIs or libraries like Lombok to do that. But for certain things, Lombok is still quite helpful.
Well, if you are not using 16 or above, if I remember correctly, so with 17 it was there for sure, and 21 as well, obviously. But yeah, I think with older versions might not be possible.
Absolutely. So, okay, so it created a bunch of files for us. Let's open a terminal and see if everything works. Uh-oh, wrong terminal. This one. CD monkey and MVW compile. Oh, actually, let's run from here.
Yeah, there is a terminal in the VS Code as well, right?
Yeah, GitHub Copilot.
Oh, you could also ask Copilot to do it for you.
Yeah. So let's.
I always wanted to be a manager, and now with Copilot, I can always just tell it what to do, and it does it so perfectly. And then if you have the next to allow, you can even use the arrow, and then it does it without you even confirming, which is risky, but also somewhat cool. And you please make sure you only allow it for like things that are safe to use, such as compile and test.
Okay, cool. So it did compile, it did run the test. Now let's use this MCP inspector project here that is on NPM. We're gonna copy and run. Oh, what happened? Could not be found.
I guess it's still starting the project.
No. The because I pasted twice. There you go.
Okay.
Okay, let's allow. Sure. So it's building. So it's trying to figure out if the project is up and running. That's the thing here. Let's just skip this thing. And no, let's pause. Let's keep. We don't want it to test. This is an interesting instruction. Don't try to test after building things. Let me do the test manually. So Maven, compile, package, Quarkus, dev.
Yeah, we are on recording. We want to show it live here.
So we're gonna do SSE, and let's say if it's up and running.
What was the port?
8080, yeah.
Okay, because it says 3001 here.
Oh, it's already up and running. That's why. It was already up and running somewhere else. So let's change the port. Yeah, good eyes. Thank you for that, Sandra.
Yeah, that's what pair programming is for.
So now we have a new README. We have a bunch of files that we don't need to look into right now. And what is the URL? MCP/SSE. This is the URL. Connect. And voila, we are connected. And we can list the tools. Now we can get a random, list monkey species, run tool. There you go. So we got a bunch of species here. Let's see, there's a proboscis monkey, Mondrial Aurora tail monkey. This is a fictional one. Look at that, fictional northern mistlands. So this is an example of creating an MCP server using Quarkus, but using the LLM. You give instructions, you give a Copilot, GitHub Copilot instructions file on how to create an MCP server. And then you tell, hey, create me an MCP server with this scenario, this use case. And it generates everything for you. All you have to do is Quarkus dev, and voila, you have your project up and running. Now, once we have the MCP server up and running, now it comes to how do I configure this MCP server in clients so I can use this MCP server within my development tool or within my ChatGPT window and so on, or a Claude desktop, or even other AI agents tools that you have in your environment. But we are done with the MCP server, so we can. You can join us on the next talk for MCP clients, where we're going to learn how to configure this MCP server to be accessed. So thanks for having us.
Thank you so much, Bruno and Sandra, for this amazing session. The only thing better than one cloud advocate is two, and we had both of you today to lead us on this amazing journey. For those of you who followed along or would like to learn more, you can find resources at aka.ms/Java and AI for beginners. Link is also in the description of this video. We hope you stick around, and we'll see you in the next episode. What do I want to order today? A barista can only make the perfect coffee, but only if someone orders. And that's the client's role. They ask, and the server responds. Hi, I'm Ian, and I'm a cloud advocate here at Microsoft, and I really love this part because once you grasp the client side, you see how developers, not just systems, drive the interaction. Clients are where user needs get translated into actual requests. And that's what makes client-server architectures so powerful. Joining me today are Sandra and Bruno, who are a powerful team. They're going to be showing us how MCP clients work, how they make the requests that bring everything to life. Guys, take it away.
Thanks, Ian. Welcome. So, Bruno, last episode we just created an MCP server. Now I would love to see how I can use this MCP server as a developer using, for instance, VS Code with its GitHub Copilot integration. And then afterwards, why don't we also create a client as a Java developer? I would love to see this using LangChain4j.
Yeah, absolutely. So we did implement a server that lists species of monkeys, and we can access this tool in different ways. We can use the inspector for MCP, which is this project here, Model Context Protocol / inspector in NPM. This gives us a very easy way to test. This is an MCP client at the end of the day, and it's good for testing an MCP server. So I put the URL here of my MCP server. I hit connect. I can list the MCP tools available on this server, and I can trigger them. So here I'm going to trigger the list monkey species, and I can run this tool. I got a list of 11 total species. I can make other calls like get random species. It just returns 1 and all the data. But this is just an inspector tool. What I really want is to get this MCP server available in an environment that is actually useful as part of my flow when interacting with AI. So what we're going to do is configure this MCP server on Visual Studio Code, and then we're going to implement an actual Java application that uses this MCP client as part of an agentic flow. If you are curious about how to do these things, it's all part of the repo Let's Learn MCP Java on GitHub, on the Microsoft organization. So let's look into Visual Studio Code first. When I ask Visual Studio Code, let's use the ask mode, and we're gonna use the ask mode for give me 3 species of monkeys. And right now, it doesn't have that MCP server configured as an MCP server on this environment. So it came up with these options here, Rhesus, Capuchin, and Howler. Now, these are probably coming from the training model of Sonnet 4, which is the model that I used for this interaction. So let's add the actual MCP server that he created for species. And let's go to here, add a server. And we're going to do localhost 8080 MCP SSE.
Yes.
Yes, is that correct?
Yeah, that was correct.
All right, monkey species MCP server. And let's available on this workspace only. And let's trust this MCP server. All right, so now we have in this workspace, in this project here, which is the MCP client project, I'm also configuring the server as an MCP server for these Visual Studio Code environment. And it already found 4 tools, as we can see here. So we can show the output. Let's see if the output shows something. This is the login of the Visual Studio Code client connecting to that server. Okay, so now let's go here and let's ask Sonnet MCP resource. Oh, not MCP resources. Let's just ask the question again. Give me 3 species of monkeys. Let's see if it will connect to the MCP server. It did not. It did not because it's not in agentic mode. Let's put in agentic mode. And let's make sure it's using the MCP server for monkeys. And let's click OK. Now I did select, all of the MCP servers in my environment were selected. I deselect all of them, and I only selected this one because I don't want the LLM go trigger all the other MCP servers. Cool, so now I'll get you 3 monkey species using the available tools to provide you with accurate information. Let's say it's an MCP server with accurate data, not just random training models. And then let's allow this execution. So we did run it did run list monkey species, and it found one species here, spidey monkey. And let's get the details for these species. And let's get the details for this one and for this one. So it got details for 3 species. There you go. So we have the spider monkey, we have the Japanese macaque, and we have proboscis monkey. Great. These are actually coming from the MCP server that we implemented before, as we can see in the source code, which, we'll skip that part. You can go back to the video and watch again. Now, what if I want to implement an application that actually integrates with the MCP server as well? So we have this code here that we already wrote, and it's an application using LangChain4j, and it has a chat model, it has a system message, you have this chat interaction with the application. We have an OpenAI key, but we're gonna actually use the local large language model Ollama for this example. We have Ollama up and running. We're gonna have an in-memory chat memory store, and we're gonna have tools. So for the tools, we're gonna use the MCP server that we configured, that we implemented. It's up and running, and here's the mcp.json file configured. We're gonna use this MCP JSON file for this Java application. So when we run this application, what we are doing here is combining implementation of a chat service with a provider and with a model. The chat service, here we add, in this AI services builder, we have a bot, which is a chat bot. We're gonna use a chat model, which is gonna be Ollama, and we're gonna use a tool provider. This tool provider is the MCP tool provider that has the MCP server we configured. So let's just run this code and see how it works. So let's create a new terminal and call java-jar. And you see I passed the argument here, chat. So now I'm in chat mode in this Java terminal application. And I can say something like, what monkey species do you know? Or give me 3 species of monkey, the same prompt that we gave Visual Studio Code. Let's go with that. All right, so it returned spider monkey, howler monkey, and Japanese macaque. So 3 species different than 2 in a different order than the one. Give me fictitious species. And these ones are fake coming from the server. Volcanic amber monkey. Give me all species you have. Let's see if it will list all of them. There you go, 11 species as we saw in the beginning. All of them coming from the MCP server. So it's not using its large language model training data set behind the scenes. It's just using the information coming from the MCP server. So this client, we have Visual Studio Code as a client, and we have a Java application as a client, as an MCP client for that MCP server. And you can configure other tools like Cloud Desktop or GitHub Copilot CLI that just got released, and Cloud Codex. All these agentic AI CLIs can also connect to MCP servers as long as you have this configuration. So go have fun. Sandra, I know monkey species is not the best example, but I mean,
That's the best example. With Ollama, you can totally run it locally, but when you also want pictures, because I would love to see pictures here, we can just switch to Azure OpenAI, and with LangChain4j, it's a quick win. It's gonna be the same code, just you, as Bruno pointed out, you just give it the secrets and the key, and then it will work.
Awesome. So thank you, Sandra. Thank you for folks watching, and have a great day.
Thank you so much, Bruno and Sandra, for this amazing session. The only thing better than 1 cloud advocate is 2, and we had both of you today to lead us on this amazing journey. For those of you who followed along or would like to learn more, you can find resources at aka.ms/Java and AI for Beginners. Link is also in the description of this video. We hope you stick around, and we'll see you in the next episode. Hopefully everybody's familiar with coffee beans. They're pretty simple, right? They all look the same at first glance. But here's the twist. With the exact same beans, you can make an espresso that's quick and intense, or a cold brew that's smooth and mellow. Same beans, Completely different experience. The context shapes the outcome. I'm Ian, I'm a cloud advocate here at Microsoft, and context is one of those things we always don't think about, but it completely changes the outcome. In coffee, but also in Java. Bruno is here again to show us how context engineering shapes Java applications and how the same code can behave so differently depending on the ecosystem around it. Bruno, over to you, take it away.
Hi, Ian. Thank you for having me. Yes, today we're going to talk quickly about context engineering and how developers and Java developers can use advanced features in Visual Studio Code to enhance GitHub Copilot and the chat feature inside Visual Studio Code. This will allow developers to provide the right context at the right time and also reuse prompts and information across the project so they don't have to be repeating themselves all the time when talking to the agentic AI in GitHub Copilot. So we're going to cover a few features in Visual Studio Code. One of them is custom instructions. The other one is prompt files. And the third one is chat mode. With these three features combined, developers can have the right context at the right time to perform the tasks. So let's take a look at the documentation. If you look at the Visual Studio Code documentation for GitHub Copilot chat, you're going to see this section here called Customize Chat to Your Workflow. Everything that I'm going to demo here comes from this documentation. So if you want to learn and deep dive into it, just go for this documentation here on code.visualstudiocode.com. So now let's go to this Visual Studio Code application. I have this Java application. It's a Maven application, and it's already running on Java 25. It's a latest version of Java. And you can see this code is very simple. There is a main method, and there is a print line for a hello world. And it's using a new class available in Java 25 called IO. With this code here, we can run this Java application fairly straightforward. Hello world. Now, what if I want to plan a new feature in this code? Now, I can have this idea of a agentic AI task where I can copy paste the text from somewhere and then just put it in here in the context for this feature, do this, this, and this with this requirement, etc. But if you're going to do that all the time, adding new features to a new code, you might as well actually have a chat mode that has that information all the time. So one of the most advanced features that we have is called chat mode in GitHub Copilot Chat. So here I have this file called planner.chatmode.md. This file defines a description for what this chat mode is about, and then also enables certain tools or MCP tools that this chat mode will use. This helps the agentic AI to not use all the MCP tools available in your Visual Studio Code installation. And finally, which model will be used when using this chat mode. Now, the last thing is, of course, the instruction. Again, you don't want to repeat yourself all the time, and you want to be able to quickly change between chat modes. So this will give you this space here where you can define what are the instructions for your LLM, for your feature. So I want to implement, I want you to be a planner. So you're going to be in planning mode. Your task is to generate an implementation plan for a new feature. And the plan has to have overview, requirements, implementation steps, and so on. So again, it's not, it's something that you very generic given a particular feature that you want to implement, but first you want to plan that feature. So let's see how this works in action. Usually you have this agent mode selected. Agent mode is the most common thing that most developers are working with. It will go and make changes in your files. But what if we have this planner, this agent with these specific instructions here? Now, I'm going to say, give me a feature where I make this program, not a feature, make this program output the current date given a time zone. Make the program output the current date given a time zone. Now, this will just implement it the first time. Now, one thing that you're going to notice was that it is implementing the plan, not the actual code, because that is my ask. You're in planning mode, your task is to generate the plan. Don't make any code edits. So the final output of this prompt is just a plan for my feature. The one thing that was what was visible here was this. At the beginning of the plan, it actually added something, date, today's date in UTC. This came from this last requirement that I added here. The plan must contain a header with today's date and time in UTC with this format. So we can see this in action happening here where the information in the prompt was processed by the AI. Now let's scale down. Once we learn this amazing feature, what are the other things that we can do that are actually even simpler? And we see this in action. Here, we see that the output actually gave us a joke about time zones. And this happened because it used two references. One reference was actually one file called copilot-instructions.md. This file is here in the .github folder, and it provides a generic instruction that will be processed whenever you talk to GitHub Copilot. Again, it's all about context. In my context, I want to have a joke about weather, about geography and climate. But you can have something like, this project uses Java 25. Make sure that you always provide code syntax that is modern and up to date with new APIs and so on. So that instruction can go here, and whenever you talk to GitHub Copilot chat, that instruction will be provided to the AI. Okay, but what if you don't want instructions to be processed all the time? You want instructions to be processed depending on what file you are editing. That's where you have the instructions folder. The instructions folder is a folder that provides the ability to have multiple files, multiple instructions with multiple context settings based on your project, on your frameworks. You can have a spring.instructions.md, you can have a hibernate.instructions.md, you can have a business requirements.instructions.md, and so on and so forth. And for each file, you can even set, I want to apply to a specific set of files. So whenever you talk to the LLM to make a change on the Java file, that's what these instructions will apply to. Finally, we want to have some prompts that we don't want them applied in any situation, but we want to have easy access to them in the chat. So instead of just going to that notepad and copying, pasting prompts, you can have them here. So let's take a look at this code again. And here, let's take a look at what this prompt is. Batpractices.prompt. This prompt here uses the mode ask, not agent, and it has a description, identify and explain bad coding practices in the provided code snippet, using Claude Sonnet 4. And then the bad practices in the identification instructions, with a list of bad practices found, a brief explanation of each one, and what are the suggestions that you can apply in the code. So let's use that here. Let's open the file, app.java, and let's make something here like string equals no, string message equals no, and then let's do message.toString. I mean, this is already bad code because we are trying to do a toString on a variable that is null. So let's run this bad practice. You see here, I did a slash, and then it shows bad practices because it's getting from that file. So let's call this thing, and let's just run this, but let's not use the planner. Let's use the agent. And let's add the app.java. So now it's following instructions in badpractice.prompt.md. Now you're gonna notice the joke again. Why did the Java developer move to Arizona? Because they had great dry heat for debugging. Bad joke, but it is a joke nonetheless. And the reason it came with the Java developer joke and not necessarily a weather joke is because it used GitHub Copilot instructions, but it also, because it's touching the Java file, it combined also this one here. making a programming joke. Okay, so now it doesn't analyze the app.java for bad practices, and then it finds something interesting. It's missing the static modifier in the main method. The main method lacks the static modifier and proper signature. This is incorrect, why it's bound, etc., etc. And then there is an intentional null pointer exception. This is a great report. It already provides information, but of course, this is happening because the LLM, the model, is trained on versions of Java before Java 25 that just came out a month ago. So the model actually doesn't know that the code syntax in Java 25 has changed, and it actually allows code much simpler like this. So what could you do to enhance the context? You could actually get the Java specification, the Java language specification, convert to Markdown, and put in your instructions.md file with all the summary of the major changes in the language syntax. That will give you that context to work even with a model that was not trained with these changes while still leveraging new features in Java 25. So this gives you best and the better context engineering to work in your Java projects. I hope you enjoyed, and if you're curious about more, visit code.visualstudio.com and learn about custom instruction workflows. Thank you.
Hey all, thanks for watching and following along with us. If you would like to find supporting content resources and the code we used, you can find them at aka.ms/Java and AI for beginners. It's also linked in the description of this video, and we'll see you in the next episode. Those of you familiar with the old Microsoft logo know that this Java cup is a little out of date. And that is what modernization it's about. It's about keeping the flavor, but giving it new life. Hi, I'm Ian, and I'm a cloud advocate here at Microsoft. And in this session, I'm going to show you how AI helps us upgrade our application without throwing everything away. Today, we're tackling a common but really painful problem: modernizing legacy Java applications and migrating them to the cloud. Whether you're migrating your application to the cloud, updating your Java runtime, modernization is rarely simple. Conflicting or depreciated dependencies, antiquated deployment targets, and lingering security vulnerabilities often block smooth progress. That's exactly where Microsoft's new GitHub Copilot app modernization tool comes in. Powered by Copilot Agent Mode in Visual Studio Code, it delivers an interactive step-by-step experience to help you upgrade and migrate Java projects faster, with fewer errors, and most importantly, with more confidence. Today, we're working with an application called Asset Manager. It's a web-based asset management system designed to handle image uploads and storage. Users can upload, view, and delete images through a gallery interface. Behind the scenes, it stores files in AWS S3, tracks metadata in PostgreSQL, and uses RabbitMQ for background processing, as well as Spring Boot with Timeleaf to power the backend and front end. So this isn't just any toy application, it's a real cloud-enabled system that mirrors what many enterprise teams run in production, making it a perfect candidate for modernization. So right now, this application is locked into AWS and Java 7. That's outdated and insecure. Upgrading and migrating a system like this would typically take weeks of manual effort. But with the new app modernization tool, we can let the Copilot agent do the heavy lifting. We'll go ahead and start by analyzing the project to generate an upgrade plan. So we'll go ahead and click on Run Assessment. Copilot will go ahead and take over as it runs the assessment. The assessment gives us a logical starting point to start looking at all the steps we need to take to upgrade our project. As we can see, the assessment is in progress, so we'll go ahead and wait for it to complete. This part is really cool to me because understanding an application you didn't write is the hardest part, and here Copilot does it in the matter of minutes. In addition, any tool dependencies such as AppCat are automatically installed, which assist with the assessment. And here's the result. a nifty UI we can use as our mission control as we start to dig into modernizing and upgrading our application. We can see issues are broken down into two categories: Java upgrade issues and cloud readiness issues. The big one we need to tackle is that we're stuck on Java 7. So we can go ahead and scroll to the bottom and we can see with just one click, Copilot agent mode will take over once again to start working on upgrading our project. Once we trigger the upgrade, Copilot will generate a structured upgrade plan. We'll go ahead and give it a few moments to finish generating the plan. There we go. So for the sake of this demo, I'm going to scroll through this, look at the execution plan, looks all good to me, and continue. But in your case, if you are running a migration or an upgrade for the first time, this is really important because this is your chance to take a look at the upgrade and make any edits using the Copilot chat as necessary. So I'll go ahead and click on Allow, and we can see now that the upgrade is in progress. Once again, the power is in your hands. The upgrade tool uses tools like open rewrite recipes to update imports, APIs, and dependencies. If build errors occur, it automatically enters a fix and test loop until the project completes. And this is really cool because it mimics essentially what a human developer does. At the end of the day, working with code is really complicated. And Copilot agent iterates through different solving systems to systematically reach the final outcome. Since this can take some time to run, I don't want to make you watch paint dry. We'll go ahead and jump to the finished upgrade in just a few moments. So if we take a look right here, Copilot just did something really cool. You can see in the Copilot chat, it says the CVE validation has identified several critical security vulnerabilities that need to be fixed. So Copilot also looks at security vulnerabilities and again will automatically address and fix them. Again, one of the very powerful aspects of Copilot agent mode. It will look at things which we would not even consider looking at until a lot later, and it systematically addresses these issues. All right, so when the upgrade finishes, we get an upgrade summary of all the changes that Copilot made. We can see that Copilot automatically updates frameworks and dependencies, performs security and CVE checks. In addition, it also points out potential issues that we need to bring our attention to as we continue with the upgrade and modernization process. So now with this upgrade complete, let's go ahead and refresh the assessment report. If Copilot truly did its job, we should no longer see any issues regarding our Java version. So let's go ahead and click on Run Assessment, and it will update our assessment report. Okay, so here's the updated assessment report. Let me go ahead and collapse this so it's a little bigger, easier to see. So success, we can see no more Java upgrade issues we need to resolve. Now we have cloud readiness, which we need to address. It's really cool because Copilot will automatically identify several issues. And for this demo, we will specifically focus on database. For instance, it recommends migrating our PostgreSQL database from AWS to Azure SQL database. So let's go ahead and click on Public Cloud, click on Run Task, and once I click on Migrate, and we do want to keep the changes Copilot is making. So once I click on Migrate, once I click on Run Task, we have again handed it back into the hands of Copilot agent, which will start working on the upgrade workflow. Once I click Migrate, Copilot will draft a plan, updating dependencies, editing application properties, and wiring up Azure SQL configs. Just like the upgrade workflow, Copilot will generate a migration plan and a step-by-step guide on what it will follow as a roadmap of sorts. As a user, we can review this and tell Copilot it all looks good. Okay, so we can see that the migration plan has been created, we can go ahead and open that up. We can review all the changes that Copilot will want to make. And once again, we can use the Copilot chat if needed to make any adjustments. We will go ahead and let Copilot loose once again by telling it we are good to go. And while Copilot continues working, we are free to go grab a cup of coffee in the meantime and come back once the migration completes. Awesome, so the migration has completed successfully. We can also go back to our progress report, open up the migration summary. We'll get a migration review, any changes it made. We can see there's no CVE issues and that everything is looking great. So this is success, at least for the first part of this migration. We can rinse and repeat this same process for all the other items in our to-do list, which the assessment report brings to our attention. It is now easier than ever before to modernize and migrate your application with the new app modernization tool from GitHub. So let's recap. We started with the Asset Manager tool, and it was on Java 7, hosted on AWS. We ran the assessment report and used Copilot agent mode to upgrade our project to Java 21. We migrated the SQL database from AWS over to Azure, and we verified that everything works with automated builds, tests, and CVE scanning. All of this was done through guided, AI-assisted steps. No more weeks of manual trial and error, scratching your head in frustration. And this is just the start. In the next video, we'll have our application fully migrated, and we will use the same tool to actually deploy this modernized application to Azure with just a single click using the power of AI. If you would like to find supporting content resources and the code we used, you can find them at aka.ms/Java and AI for beginners. It's also linked in the description of this video, and we'll see you in the next episode. Brewing coffee at home is fine, but it only serves me. The moment more people show up to my house, I'm scrambling. Deploying to the cloud is like opening a cafe. Suddenly your Java is available to anyone, anywhere, on this planet, maybe the next, who knows. I'm Ayan, and I'm a cloud advocate here at Microsoft, and in this session, we will see how deploying to the cloud takes our apps from personal to global, and we'll see how easy it is. So far, in the last video, we modernized our application, we upgraded to Java, fixed dependencies, and migrated our database into Azure, as well as all of our other resources that were previously on AWS. But we're not done yet. The final step that everyone really cares about is actually getting it to the cloud. Traditionally, deployment is one of the most painful parts. You have to provision infrastructure, write YAML files, configure CI/CD, and make sure everything ties together. For many teams, including myself, this is where projects get stuck. That's where the GitHub Copilot app modernization tool really comes into play. Inside VS Code, we can call the deployment workflow. Under the hood, it uses the Azure CLI, AZD, to provision resources and deploy your app. Just like with upgrade and migration, Copilot handles this iteratively. It generates a deployment plan, proposes the Azure resources that are needed, and starts applying them. If something fails, Copilot retries, adapts, and keeps on going until it reaches a successful deployment. So let's go ahead and open up VS Code and get started. Here is the Copilot application that we want to modernize. We'll open up our app modernization tool, go to tasks, and we see that we have deployment tasks. We can go ahead and click on provision infrastructure and deploy. As soon as we click on that, Copilot immediately starts an agent session. It will scan the full project and then generate an architecture diagram and then a deployment plan, which we can review. We'll give it a moment for it to generate our architecture diagram. All right, so we can see that the architecture diagram was created. Copilot jumped the gun a little bit, and it's continuing to work on the deployment plan, but that's OK. We can still review the architecture diagram. We can cross-check the Copilot agent's understanding of our application. And if we need to, we can use Copilot chat to make any revisions and make any changes. Since Copilot is already continuing, we are good to go. It's already working on creating the deployment plan. Once we have the deployment plan, we will again review it and see if we are ready to jump into the deployment. Okay, so here is our deployment plan. The deployment plan is an overarching document that will be the instructions Copilot follows when deploying our application to Azure. We once again get the architecture diagram. We can review and make any changes needed. It gives recommendation for Azure resources that it wants to deploy, as well as step-by-step instructions that Copilot will follow. So once again, if there are any changes, we can use Copilot chat to make them. But if we're good to go, we can tell chat to continue, and it will start working on deploying our application. Now that we've let Copilot loose, it'll start iterating over the project, deploying our resources, and depending on the complexity of the project, this can take some time. So I won't make you wait here. We'll wait for this to finish running, and we'll be back once we have success. All right, we are back. Our deployment was successful. We can open up Azure portal and we can see all of our resources were successfully deployed. In addition, we can open up App Service and navigate to our application. We should see that Asset Manager will be up and running. All right, and we will open up our site. Aha, we can see our application is deployed, and it seems like Copilot did some nice UI enhancements. You can see there's some issues, such as the upload new is a little faded away, but we can even test our application. We'll click on Upload New. We will browse some files. This is a nice graphic that Matt here in the studio made for me earlier yesterday. So we'll upload it. And once it finishes uploading, we should be able to view it in our gallery. OK, here it is. It's in our gallery. So the application is working. We can see there are some flaws, but all things considered, given that I literally clicked one button, I am beyond thrilled at what Copilot did for us today in deploying the application. I really love the new Copilot app modernization tool. Using the power of AI, we literally get a full team of developers just one click away. An otherwise complicated process is now streamlined using the power of AI, and in just a single afternoon, we have modernized, migrated, and deployed our application to Azure. I took a few coffee breaks myself in between, and Copilot worked for me. I now pass the baton over to you to try Microsoft's new Copilot app modernization tool for Java. If you would like to find supporting content resources and the code we used, you can find them at aka.ms/Java and AI for beginners. It's also linked in the description of this video, and we'll see you in the next episode. This mug I've got here, it just holds coffee. But have you ever seen those mugs where when you pour in a hot liquid, it changes color to indicate that there's something hot inside? It's smart, adaptive, and intelligent. In the age of AI, we have grown to see adaptive intelligence everywhere. It's increasingly more important than ever that we are able to understand how we can create applications that integrate AI. Hello, everyone. I'm Ayan. I'm a cloud advocate here at Microsoft. And joining me today is Julian. Julian is going to be talking about and showing us how LangChain4j brings some of that intelligence to Java applications. Julian, so excited for this session. Over to you.
Thank you so much, Ayan, for this introduction. Like you, I do believe that Java is a great platform to build AI applications today with some great tooling that is already available, like LangChain4j or Spring AI. I'm Julien Dubois. I'm working with Ayan in the Java developer advocacy team at Microsoft. And I'm also one of the core contributors to LangChain4j, where I implemented the official OpenAI Java SDK integration. That's what we're going to use in this video today. To do that, I've worked both with the OpenAI team and the LangChain4j team, and we're going to see how easy it is to use both tools today. We're going to do a small demo in 4 parts. So we're going to set everything up. We're going to configure LangChain4j. We're going to run it, and we're going to test it. At the end of this video, you should have a good understanding of how LangChain4j works, so you'll be ready for the next video where we'll do agents, which is a little bit more complicated, but also more interesting. So let's get started. And when I want to do a very simple Java project, usually I go to start.spring.io. That's what we're going to do right now. So here it is. I've just selected Maven because I want to add Longchain4j and I want to show you how to add some dependencies using Maven, as it's the most commonly used tool for dependency management. And I've selected Java 24 because I like to have the latest version of everything. I'm not adding any dependencies because we're going to do something extremely simple, so we don't need anything yet. I've created the project, I've downloaded it. Let's open it up. Here it is. I'm opening it with IntelliJ. It will work the same with any IDE like VS Code, of course. Let's run the project to see if everything is fine. Here it is. Again, it's extremely simple and it's not going to do anything. It's just going to run the Java application and stop because there's nothing to do. Let's add something a little bit more interesting. For that, I'm going to use GitHub Copilot. Let's go to agent mode. Let's use Claude Sonnet because I find it better. And let's ask it, add the Spring command line runner to ask a question to the user. Of course, I could have coded it myself, but it's much faster to ask GitHub Copilot to code it for me. So this is going to update my Spring Boot project and add some simple Java code to ask some information to the end user. Here it is. Let's accept this. So let's run it again and let's see how it works. Now it's asking me a question. What is your name? So my name is Julien. And it's saying, hello, Julien. So we've got a question and an answer. We're not using AI yet, so it's very basic, very simple. If we want to do something a little bit more interesting, of course, we want to add AI to our application. So let's get started and let's add Longchain4j. For that, I'm going to go to the main Longchain4j documentation. You can do the same here, of course. The advice here is to add the dependency that you need for your application. I'm going to do something a little bit more complex. If we go down here, we're going to use the bill of materials. So that's a Maven configuration. The interesting thing here is that Longchain4j is separated in many different modules. You will probably want more than one. Well, for something as easy as today, probably you only want one, but that example is probably too simple. If you want something realistic, you will want several modules. So you want dependency management here. So all your modules have the right dependencies automatically coming from this bill of material. I'm going to add it in my pom.xml right here. And I'm going to add our dependencies just above. So we've got integration in Longchain4j with many large language models. For example, GitHub models, Mistral, Olama, etc., etc. I want to use the OpenAI official SDK. So you've got also an unofficial SDK, which might work better if you use Quarkus or Spring because they're using the underlying HTTP client. But I'd rather use the official one from OpenAI because you've got the latest version of everything, which I find is better in the long term. The dependency we need to use is this one. Let's copy paste it. And as we just use the bill of material, we don't need to add the version. That's why I wanted to do that earlier. It's a lot easier now to use. So Longchain4j is integrated into my project. I'm just forcing Maven to reload it to be sure that everything is fine. And now I can start to configure it and then, of course, use it. Let's go back to the configuration, to the documentation here. Here is how it is supposed to be configured. So let's copy paste this and have a look at how it works. I'm going to configure it right here. So we're going to use a chat model. So that's an interface. Let me import it. The chat model comes from Longchain4j. That's an interface. So all implementations will use the same interface. That's why it's interesting to use Longchain4j. One of the main reasons to use it, you can change implementations very easily, as you will only rely on the interface for your coding purposes. So I've got that interface that allows me to chat with any LLM. And then I need an implementation. In this case, we're going to use the official OpenAI SDK implementation. I'm going to import it. Let's just have a look. as you can see, it's a bit more complex. It's a real implementation that connects to OpenAI and gets the answers back and passes everything. So it's quite complex. And as we can see, it requires 3 parameters. There are a bit more parameters if you want to, but there are 3 main ones. The first one is the URL, then the key, and then the model that you want to use. Let's get those parameters and configure them. For that, I'm going here to ai.azure.com, to my Azure AI Foundry instance. As you can see, I've got several models which are already deployed. I'm going to use GPT-5 Mini. There is some documentation here to help you, typically with Java. Here it is. You've got different SDK, like here's the OpenAI SDK that we are using. That's what we are using underlying Langchain4j. So what we want is the first thing is the URL. So we're going to copy that. And we need only the base URL, as the name suggests here. So let me copy this and only use the base URL, which is this one. The second thing we need is a key. So the key is here. Of course, in a real application, you shouldn't hard code the key here. I'm only doing this for the demonstration. And I will rotate my key just afterwards, so it's useless. And the last thing that we want to use is the model name. So we're using GPT-5 Mini. So we've got also some constants to use that, but you can just type it. It's extremely easy. So with that configuration, my model is able to access GPT-5 on Azure, and we're going to be able to query it and ask it some questions. Let's do something here, of course, with the answer. So the question, what is your name? So we're going to say, please write a nice poem for a person called, and here's the name. So that's what you will typically call a prompt when you use AI. And we're going to send that prompt to our model. So we're going to do model.chat. And that's the prompt that will send to the chat. The answer to that chat is going to be a string, which is the answer from the LLM. Let's run this again. So it's asking me my name again. Let's put something a little bit more fun. My name is Java. And let's see if we can have a nice poem about Java from GPT-5 Mini. Here it is. Java, you arrive like morning, warm and steady, blah, blah, blah. It's talking about coffee, of course, because Java also in English means coffee. So here's how you can add easily support for AI to your application. That's only generative AI with text. If you want to use images or audio, it's basically the same. It's just not the same implementation, but it's basically the same thing. If you want to use other LLMs, it's also the same idea. You just change the implementation, and you've got here an easy-to-use interface to query it and get the answers. In the next video, we're going to do something a little bit more complex by doing agents. Agents will be different LLMs talking together and working together for doing something more complex than just what we've seen here. So see you at the next video. Thank you.
Hey, Julian, thank you so much for showing us how we can easily integrate AI into our own applications. If you also want to learn and take your first steps to integrate AI, you can go to aka.ms/Java and AI for beginners to find resources. It's also linked in the description of this video. We will see you in the next episode. Sometimes I get so absorbed in my work that my coffee just sits there. But imagine if it could order a refill on its own or warn me when it's cold. That's exactly what an agent does. And today, we have Julian joining us. He'll walk us through building agents that don't just sit there, but actually act on our behalf. I think that's super cool because I could use an agent or two. Julian, please teach us how. Over to you.
In this second video of our Java and AI Basics series, we'll focus on creating AI agents using Java and Langchain4j. So what is an AI agent? It's a program that can perform tasks on the behalf of a user by understanding natural language commands and taking appropriate actions. The initial power of such an agent lies in its ability to interact with various tools and APIs in order to accomplish something complex. But the true power comes when different agents work together and combine their unique strengths. In this video, we're going to use 3 agents and make them work together to achieve something in common. So the first agent will be an evolution of what we created in the first video. It's an author who is able to write a poem for you using an LLM. The second agent will be an actor. The actor will be able to transform a text, so this poem, into an audio file. For this, that agent will use another LLM and will use a tool which is able to transform a text to an audio file. The author and the actor will need to work together, and for that we need a third agent, which we'll call the supervisor. The supervisor will be able to coordinate them and orchestrate them so they work together correctly. Let's have a look at how this is using a whiteboard. So here we are. The user, so you, would be here on the left. Let me draw a little person here. And you're going to ask the supervisor, please write a poem for me on this specific topic. Then the supervisor can orchestrate the author and the actor to achieve this goal. There are 2 ways to orchestrate those agents using Longchain4j. Either we use what we call pure AI. So the supervisor will use an LLM like here GPT-5. And using that LLM, it will decide by itself which agent to call first, which agent to call second, and if they call them at all. That's probably the most powerful way to use AI agents. And that's what we call pure AI. The second way to use the supervisor is to use an API, which is pretty rich in Longchain4j. And that API describes the workflow. So the workflow that we would use here is a sequence. We call first the author and then the actor. That API is, of course, rich. There's more complex workflows than just sequential calling. You can do loops, you can do parallel callings, etc. But you get it. It's either you use AI to orchestrate your agents or you use a workflow. In this example, which is going to be very simple, we're going to use a sequence. So we'll ask the author to write a poem and we'll ask the actor to tell that poem. Now, how do those agents work, the author and the actor, which are, let's say, sub-agents for the supervisor? So the author will use GPT-5 mini here to create the poem. It will get it back and it will send it back to the supervisor. Once the supervisor got the poem, it can call the actor, and the actor will use another LLM here, Ministral 3B from Mistral. We're using here another LLM just to show that it's possible. And why would you use another one? Maybe because it's more accurate for what you're doing, maybe because it's faster, maybe because it's cheaper. You've got different reasons to change your LLM, and the LLM is linked to an agent. So Mistral will come back to the actor and will use a tool called MauriTTS. We'll detail what it is just afterwards. But that tool is able to do text-to-speech. That's what TTS means. And it will transform the poem into an audio file. It will come back to the actor, which will come back to the supervisor, and which will come back to you with the finalized file. Now, this all work together also because thanks to Longchain4j, you've got a shared context for all those actors. So they will share the text of the poem, the audio file, etc. So they can answer you and work together. Now, let's code this and understand better how this all works. So let's go back to where we stopped with the first video. And on the first video, we stopped here with the command line runner, which was calling OpenAI and sending back the poem. So we're going to do something a little bit more complex, of course, now. We're going to transform this into our first agent. Now, how do we do this? Well, first thing is that we need to add a new dependency to have agentic support in Longchain4j. So there's a new module in Longchain4j, which is called, you guess it, agentic. Here it is. And I'm just going to refresh Maven to be sure that my class path is up to date. Now we've got agentic support in Longchain4j. Let's code our first agent. So I'm going to say new interface. And that first interface will be the author. So we'll call it author agent. So the author agent, what does it do? It creates a string and it writes a poem for you. Instead of putting a name, let's put topic. So will have a topic, and it will write a poem on that topic. It will send back this string. Let's just come back here. Welcome to the demo application. What is your topic? And it will come back with the topic here. So let's now configure that agent. Here you need basically two annotations from Longchain4j. The first one is called user message. So that's the message that our user will send to the LLM. And so the message will be something like this. Write a poem about this topic. So here, autocompletion does not understand yet the specifics of the template language that we're using here. So you need two curly braces and not one. We'll see that it's going to learn, and so next time it will work correctly. So write a poem about this topic. That's our first user message. And we can also add a second annotation here, which is called agent, just to tell the agent who he is. And so you are a poet. Yeah, write a poem about this given topic. We could be more specific. You could be like a 19th century poet, a romantic poet, that kind of thing. And the user message is what we ask it to do. So write a poem about this specific topic. So the first agent is done. Let's configure it. So auto agent. So for this, we're going to use the agentic services from Longchain4j. We'll tell it to create an agent using the interface that we just created, the auto agent. It's going to use a chat model, so the one which is above, using GPT-5 Mini. And well, we're going to build it. And that's not all. We also need one more thing, an output name. So this is going to output our poem. So let's call the output poem. So that's what I called just before the shared context. So the context first will have a topic. That topic will be sent here, and it will give back a string, and that string in our shared context will be called poem. That's the poem that we want. Let's write the second agent now. So the actor, let's actor agent, which is also an interface. So that actor, what does it do? Well, it's going to give back a string, which could be like the file name. It's not very important. And it will transform this poem to an audio file. And yeah, it will take poem as a string. Let's add two annotations like before. So the user message. So let's tell it, transform the poem into an audio file. That's pretty good. And again, it understood, oh, this was wrong. And it's missing here a quote. So yeah. Come on. Yeah, this is good. Yeah, Copilot messed up a little bit, but then here, as you can see, it understood my new templating system that we just used before. So it's pretty smart. So transform this poem into an audio file. And this agent is a voice actor. So you are a voice actor. Yeah, we don't need that because that's basically what we are going to ask it to do. So the agent is what it is, and the user message is what we tell it to do. Let's configure it like we just did before with the author. So actor agent. So agentic service, agent builder. So it's not going to use the same model as, actor agent. It's not going to use the same model as before. We said we wanted to use Ministral 3B. So let me just copy paste this, create a new model here. Let's call it Ministral. And Ministral, no, 3B. So we're going to use Ministral as our LLM. And we're going to need a tool to transform our poem into an audio file. So let's add a tool here. New text to speech tool. And we're going to need to code this one, of course. let's create the class and have a look at how we configure a tool using Langchain4j. So for this, we're going to use, as we explained in the introduction, we're going to use MawiTTS. So it's a Java program that transforms a text into a voice. It's written in pure Java, so I'm using it because I'm a Java person, but here we're just going to use it running on the side, so it could be anything. I've already coded the integration. Let's have a look at how this works. Let me just take the code here. Here it is, and here it is. So first of all, we're going to use Docker to run MawiTTS inside a container. So let's open up a terminal. Let's copy paste this. And MawiTTS should be running now inside the container. If we use Docker here, go to dashboard, here it is. It just started. Wonderful. Now, what are we doing here? So we've got a notation add tool. This is used by Langchain4j. So we tell Langchain4j, this tool converts the provided text to speech and saves it as output.wav. So this is what the tool can do. And then this is, of course, specifically coded to use MawiTTS. So basically, we send the text file through an HTTP request, and we get back some stream, and we write that stream to output.wav. So we'll have here an output.wav file which will be created. So let's go back to the configuration here. So the actor agent now uses Ministral as an LLM and uses our text-to-speech tool to generate the file. Now we need to link all of this together. So for that, we're going to use our supervisor. So here is how it works. So this time, I'm not creating a specific class for this. It's something very generic. I'm going to use an untyped agent. I will call it supervisor. And it's going to be using sequence builder. So the sequence builder will be a sequence of the two actors that we just, the two agents that we just configured before. Those will be called here sub-agents. Sub-agent 1 is the author. Sub-agent 2 is the actor. And we don't need a tool, we just need to build that. And now in order to run this, we're going to create a context that will be shared between all those agents. So let's create a map for this. It's a map of string and objects. We'll call it context. Yeah. And let's import this. So what's happening here is that we create a context. In the context, we put a first item, which is topic. So topic is what we have here. So that's the topic of the poem. Once this topic is transformed into a poem here, there will be, of course, a new item in our map, which will be the poem. It will be sent to the actor, and the actor then will create the wave file out of that poem. Now, let's run this. Supervisor.invoke the context. And let's run this to see how it all works together. So it's asking my topic. So my topic is the Java virtual machine. And let's wait a little bit. This should create an output.wav file here with our poem told by the voice actor. And that should be pretty fast. So yeah, don't expect that poem to be wonderfully said, to have something a bit fast running inside Docker. We're not having a very good text-to-speech system. So the output.wav is here. Let's call it VLC. So I'm using VLC, which is a cool French open source software to listen to music and files. And here it is. Let's listen to it.
Beneath the glass and icons, humming in the dark, a quiet engine reads a language of steps and sparks. Byte code minus neat soldiers folded from a
So now that we've
source
seen how we
minus
can
mark.
create agents in Langchain4j, let me summarize what we just saw. So let's go back to the dashboard here. So again, what we saw is that we can make agents work together and be orchestrated by a supervisor agent. Those agents can use one LLM and can use one or many tools. They should be pretty specialized. So they're going to use an LLM which is specific for what they want to do. And they're going to use a minimum set of tools. If they have too many tools, they will be confused like anyone. And those tools are there to help them act and create something on your behalf. And then also just to summarize what's very important here for the supervisors, there are two ways to orchestrate your agents. Either you use pure AI, and so you've got another LLM, you send it the text and it decides which agent to call at which moment. Or you do like I just did here, we have a workflow API, which is more direct, maybe a bit more simple, but still pretty rich for normal usage. And that gives you more control on what you want to do. So we are coming to an end of this video. Thank you so much for following it, and see you in another video. Thank you. Goodbye.
Hey, Julian, thank you so much for showing us how we can easily integrate AI into our own applications. If you also want to learn and take your first steps to integrate AI, you can go to aka.ms/Java and AI for beginners to find resources. It's also linked in the description of this video. We will see you in the next episode. Have you ever tried to whisk milk by hand? I actually hadn't until this morning, and 5 minutes later, my arm was sore and I was running late to this recording session. And I still had flat milk. Some jobs just demand a little bit more horsepower, which sometimes requires some special tools, like this electric whisker. Now watch this, same milk, same goal, but I turn this baby on, put it in the milk, and it's faster, smoother, and easier. And that's what GPUs bring to generative AI in containers. They don't just speed things up, they make the whole process practical at scale. I'm Ian, and I'm a cloud advocate here in Redmond, Washington at Microsoft HQ. And today I'm joined by Brian Benz. Brian is here to show us what that looks like in action. GPUs aren't just a luxury add-on. They're what take Gen AI from fun demos to real-world workloads. Brian, let's go ahead and dive in.
Awesome. Thanks, Ian. So what I'm going to show you today is a little demo that I put together for running Gen AI in containers with GPUs. I built a model and a repo that basically creates images for you without going out to an image service. And I'm going to start with a demo, and then I'm going to show you how it actually works and how I actually put it together. All right, so this is the demo. It's not running right now, but basically you can generate an image, and there's the last image that it generated. It was a watercolor of fall colors in forest with a lake. You've also got text embeddings that you could do as well. But I'll show you how all this works in a second. First, let's get the actual demo started. To do that, I'm going to go to Visual Studio Code. I've already created a Docker image, so I can just say Docker run, and it's going to run this image in a container for me. It's a Spring Boot application. It uses several different things, including Onyx, Stable Diffusion for image generation, NVIDIA CUDA for accessing the GPUs, and a bunch of other stuff that I'll explain afterwards. But let's get started with the actual demo. So I can go to this demo at localhost 8080 now, which is this. Fire it up. Okay, so here's a clear one. And I've been enjoying watercolors lately of a pine forest and lake. Just something simple like that. All right, so what this is going to do, when I hit this button, it's going to fire off a process, and it's going to create several images. So down here, if I scroll down past the performance warnings, it still performs pretty well. But what this code does is it actually loads a couple of things from Stable Diffusion, a couple of things that it needs to generate images, including VAE and a couple of other things. It's going to use CUDA to access the GPU on my local machine. And it's going to have a model, Stable Diffusion 1.5. There's a model path that's built into the repo over here. Right there, you can see the models. And what it does is it actually generates, as part of Stable Diffusion, there's some built-in text. So Stable Diffusion is a text-to-image generator. It creates a prompt. So I created a simple prompt, which was watercolor of a pine forest with a lake. And basically, the image here is actually creating a meta prompt for me. So it's added in some information based on a couple of things. And it also has some safety checks that it does. And then it actually starts generating the embedding, and it does inference steps. It does 40 inference steps, steps 40, guidance 7.5, seed 42. That means it has some images that it uses as a seed, and it has some guidance that's built into it as well. That's one of the things about Stable Diffusion. So it's going to go through 40 inference steps, and basically it's creating image layers. It created the 40 layers. Is going to decode it. It runs the safety check to make sure there's nothing unsafe in here based on some parameters that are in the default Stable Diffusion safety check, generates the image, and it created it in 80 seconds. So let's go ahead and look at that image. There it is. Hey, nice. So 1 minute, 32 seconds. The code also, so I used NVIDIA CUDA to access my GPU. It falls back to a CPU if the code doesn't actually have access to a GPU. So it'll work on either, but it takes over 5 minutes to generate the same image. So what would you actually use this for? Image services are great, and I've gained a new appreciation of how they work and how good they are by building my own example from scratch on my local machine, but they cost money. So if you are just generating a one-off image once in a while, it's probably faster and better to use one of the image generation services out there. We have some built into Azure, and there's others as well. But if you have to generate 10,000 images or convert 10,000 images from one thing to another, maybe create cartoons from photos or whatever, then using something like this solution where you run everything locally is the way to go. And you can use a GPU. Mine's a pretty primitive GPU on my laptop, but you can also deploy to GPUs on Azure, on virtual machines and something called Azure Container Apps. All right. So anyway, there's another thing here that I can show you. It's less exciting, but it just runs a text comparison to see what the similarity is between these two pieces of text. And if you have a large piece of text, obviously it's better, but this is just a similarity score that runs. And if you look at the code here, it actually checks the similarity score here. And it's much faster on the GPU than it is on a CPU, once again. So how to actually build all this? Let's talk about that a little bit. The first thing I had to do was get Stable Diffusion. So if you look at my Visual Studio Code here, you can see the models. I've downloaded two models. The one's called Mini LM L6 V2. The other one is called Stable Diffusion, and it's got a safety checker, text encoder, UNet, and VAE decoder in here as well. These are all things that go into image processing, but I needed to talk to Java and make sure that I could access these and run them locally. To do that, there is a tool, basically an interoperability set of libraries and standards called ONNX, Open Neural Network Exchange. You might have seen that in the command line when I was running this. So basically what that does is allows you to, if I go down here, the key is right here. The technical design, they provide a definition of extensible computational graph model, as well as definitions of built-in operators and standard types. Great. Okay. So I needed to use the ONNX basically decoders and to work with Stable Diffusion. All right. And then to get Stable Diffusion, I could have gone to Stable Diffusion website, downloaded Stable Diffusion, and encoded it and built in the framework around it to be used by code myself. But Hugging Face had inside they have Onyx community. They have 796 models built by Onyx community. And one of them is Onyx Community Stable Diffusion v15 Onyx. Okay. So I was able to download this. Whoops. I was able to download this. And then I was able to make that part of my code. So once again, getting back over here, we have the code that I was able to download. So you just download this, great. But then how do you actually access it from Java? Because you have to do all these functions, check for safety, text encoder, UNet, and VAE decoders. It's just part of image processing that you need to do. So I could download these from Stable Diffusion, but then how do I actually access them in my code? That was the next tricky part. And for that, I used something called SD4J. So SD4J is called Stable Diffusion in Java. It's an Oracle repo, and it's open source. All of the things I'm showing you here are open source and public domain, which is great. So I was able to include them in my app. But Stable Diffusion in Java is a modified port of the C# implementation for Onyx runtime, but it's written in Java. So this saved me a ton of time. It targets Onyx runtime 114. And by the way, this was the hardest part, was making sure that all of the different versions of Onyx, SD4J, and CUDA worked together to access my GPU and make that run in 1 minute versus 5 minutes with no GPU. These are some of the examples, but inside of here, there's great code and a text tokenizer, which you need as well for actually building this. So I was able to make this part of my repo. The last piece of the puzzle is CUDA. So CUDA is an NVIDIA tool that allows you to access GPUs, and any NVIDIA GPU, whether it's running on your local laptop or on a server or in a virtual machine or what we call Azure Container Apps, runs through CUDA. And then CUDA, you call your Java code, you call CUDA, and CUDA accesses the GPU, finds a GPU that it can use, and runs all the processes on that GPU. And once again, I mentioned it falls back to a CPU if it can't find anything that runs. But really cool stuff. Putting all this together only took a couple of days. And the way I did that, I could certainly have coded it by hand. It probably would have taken a month, or I don't know how long it would have taken. But there's so many pieces here that basically making them all work together and making them all compatible with the different versions that you need to use is pretty complex. So to do that, I'm not afraid to admit that I used some large language model performance enhancing models. And in this case, I used agent mode in Visual Studio Code, GitHub Copilot with Claude Sonnet 4.5. So Claude Sonnet 4.5 is really, really good when you've got sort of a green field and you need some advice on how to build things. And then you actually need to perform the code checks and debug your brand new code. There's another new model that's out, GPT-5 Codex, that I find is a bit better for refactoring as well. I just want to mention those two. Those are brand new as of this recording. But Claude Sonnet 4.5 really, I have Claude Sonnet 4.5 to thank for a lot of the code that was generated here, or to blame if there's something wrong with it. And one of the cool things it did is I had it put together a prompt, a really complex prompt here. Before we started, it's 750 lines, and it even includes source code and some of the things I needed to build Maven and all that stuff for Java. So 753 lines prompt. And then you put that prompt into GitHub Copilot and in agent mode and basically just let it generate the framework of the code. Then it took 2 or 3 days of debugging to actually make this work. So that in a nutshell is everything that I wanted to show you for running GenAI containers for GPUs. Please do check out the code at aka.ms/GPU on Azure. Let me know what you think of it and enjoy.
Hey all, thanks for watching and following along with us. If you would like to find supporting content resources and the code we used, you can find them at aka.ms/Java and AI for beginners. It's also linked in the description of this video, and we'll see you in the next episode. Today, we're talking about Java, but not just Java. We're talking about Java in containers. But there's also more. And I know this box seems like overkill, but trust me, there's a good reason. I'm Ayan, and I'm a cloud advocate here at Microsoft. And I'm joined again by Brian, who will be teaching us all about dynamic sessions, keeping GenAI running smoothly inside containers without resets. Imagine a container is like a box that lets me ship Brian a fresh cup of coffee. Once Brian finishes the cup, I'd have to brew a brand new cup, put in a brand new box, and ship it all over again. That's how a regular AI session might work. But with dynamic sessions, you don't need a new box every time. I can use this exact same container, and Brian can just keep refilling his cup. It's like instead of just shipping him 1 cup of coffee, I've shipped him the whole coffee machine inside the box along with the cup. In AI terms, that means the model keeps its context alive and keeps running smoothly without resets. Brian, I hope you received the coffee I shipped you. Now over to you.
Thanks. That's great. Just the way I like it. All right. So we're going to be talking today about dynamic sessions in Azure Container Apps. First of all, I think I need to explain a little bit about what dynamic sessions are, just to give you an idea of what they are and what they're useful for. Let's start with an introduction to LangChain4j. So LangChain4j is a way to integrate easily different parts of large language models into your code. In this case, LangChain4j is built for Java. There's also LangChain for Python and JavaScript. But today we're going to focus on Java and LangChain4j. So LangChain4j specifically has unified APIs. It has a toolbox, and I built one of the tools I'm going to show you here in a second. And then it's got a bunch of examples too. Let's dive into the GitHub repo for LangChain4j. And you can see it's got things like document loaders, document parsers, transformers for documents, embedding stores, so that's embedding different large language models, things like that. We also have specific things or specific capabilities for different vendor tools, including Anthropic, Azure, and a few others. The thing I'm going to show you today is code execution engines. So code execution engines, there's 3 of them in here. One of them is the one I contributed. It's Azure Container Apps Dynamic Sessions. There's also a couple of others as well, but of course, another's good. But we're going to focus on Azure Container Apps Dynamic Sessions today, and I'll show you a little bit about how that works. The other part of LangChain that we have is LangChain examples. And the LangChain example I'm going to show you actually calls the Azure Container Apps Dynamic Sessions tool that I contributed and shows a little bit of a demo. So I'm going to hop into Visual Studio Code before I go any further and show you what it actually does and how it works. And then we'll explain a little bit about how it actually does what it does. So let's just start Java. And basically what this code does is it goes out to my Azure Container Apps Dynamic Sessions that I've already created, and it asks a question from OpenAI, and it integrates that question into some code that it generates on the dynamic session. So in this case, I asked the question, if a pizza had a radius of Z and a depth of A, what's its volume? And the answer should be in valid Python code. And the answer is the volume of a pizza can be calculated using the formula. And here's the formula. Then there's an example usage and basically a few other things here. So that's just a quick example. Why is this useful? Basically, let me give you another example. When you go into ChatGPT and you create, or any chat AI service, and you create a downloadable file, say generate a PDF of what you just built for me. When it downloads that, when it actually creates that PDF, it uses a code execution engine to do that in the back end. What if you could have your own code execution engine with complete control over it that you could use to run code, test code, build downloadable files, things like that? Basically, that's what code execution engines do. And LangChain for J adds functionality to be able to easily access large language models, clouds, and all kinds of other tools to actually make that easier to happen. So generating a file, there's lots of facilities there for generating a file. The second part of this demo, basically we're logging into Azure Container Apps, dynamic sessions. And you can see here, it tries all kinds of different ways. That's part of the code I have. And then it uploads a file, Hello World Java, and it downloads a file usually. Today seems to have a little problem with that. Normally it downloads a file and then it lists all the files that are in that session. Now, how does this actually look on Azure? Let's go into Azure and show you that. So I'm actually in Azure Container Apps. So this is the Azure portal, portal.azure.com. I've got a Azure Container App set up called my Azure Container Apps Dynamic Session Pool. And that is what you use to actually execute the code. That's your code execution engine. It's part of the resource group I have is BBenz ACADS, where I have an Azure OpenAI instance and the session pool. So the session pool itself, I actually have a way of interacting with that here in the portal. So I can play around with this here. So I can actually take the code that we generated here, just as an example. This is code that was generated inside the execution engine, but it didn't run the code, right? It just told you how to run it. So let's go ahead and copy this code. Oh, and we'll go through the example usage and put that here. Run the code, and it gives you an output, hopefully. Unexpected error. Never mind. Hold on. I can fix this. So let's go ahead and paste that code in here. And there's the Python code. We can actually run it. And it comes out and says the volume of pizza is 1.570 cubic units. Yeah, so it's actually creating the, I think it's cubic centimeters. Anyway, it runs and it gives you a standard output. So the idea here is, you get the idea. You can actually go into your session, run some code, execute some code, and you can call it programmatically through the example that I provided in Visual Studio Code, and then run it from there and perform results, upload files, download files, things like that. The cool thing about that as well is that when you're running that, it can also have access to an OpenAI instance, which is what we have here. So we're actually using just GPT-3.5 Turbo and accessing the code that generates that Python. And the manipulation of uploads and downloads is done through other things. So let me show you the actual code here. We'll just run through that real quick. And it calls a tool over in LangChain4j, but this one's in LangChain4j examples. So the first thing it does is it just creates a connection and a simple HTTP client for interacting with the OpenAI instance. And then it calls that pool endpoint that we have. It sets up OpenAI key, OpenAI endpoint. These are all environment variables that are already set up in advance. And it creates a chat model. So it calls chat model with the API key, the endpoint, the deployment name. So it goes out to the large language model that I showed you earlier, the ChatGPT 3.5. And then it builds this assistant and it actually runs the query that you want and returns an answer. Then we've got some other examples for uploading a local file, downloading a file, and listing files. And if we move over to LangChain4j, the sessions REPL tool Java is what it's actually calling inside of LangChain4j code execution engine, Azure ACADS. And there are corresponding tools in here to do everything. So you've got a file uploader, file downloader, file lister, and up above there is a way to access the OpenAI capabilities as well. Here we go. So basically, the whole tool is already built, and you can access it and use it with a minimal amount of code here. There's 275 lines of code that are generating that example and showing you how to upload, download, list, and access OpenAI as well. All right, folks, so that's how to actually run GenAI in containers using Azure Container Apps dynamic sessions, including LangChain4j, and I've provided an example. Check out the examples at aka.ms/example-acads, and let me know what you think.
Congratulations on making it to the end of the series. Thanks from everyone on the team who helped make this series possible. If you want to continue your learning journey, you can visit aka.ms/Java and AI for beginners. If you want to stay up to date with the channel, please like, subscribe, and hit the bell notification icon. We hope to see you again soon.